The carbon dioxide matrix behind global drying and local flooding. This is a summary of a major web segment of timeism.com. A critical key is missing from the controversy on global warming and climate change from CO2 as a greenhouse gas. Carbon dioxide is a desiccant, that is, it soaks into and soaks up water. For example, those little packets you find in electronic gear are desiccants to reduce moisture in the packaging. Carbon dioxide readily dissolves into water, for example, beer and soda pop. In the atmosphere, carbon dioxide soaks up rather than soaks into water. The simple mechanism by which carbon dioxide is an atmospheric desiccant is how it forms clusters that bind 34 molecules of water to a single carbon dioxide molecule. The water bound in these clusters are not readily available for other particulate binding, which form the basis of precipitation, rain, snow, etc. Increased atmospheric carbon dioxide alters the dew. Droughts and floods from rapidly rising levels of atmospheric carbon dioxide will metastasize social, economic, and political collapse long before global warming burns us up. This is what has happened in The causes and sources of global warming are widely recognized by honest, intelligent people who are not financially obsessed to obscure or shade the truth. While the people of the United States has the highest per capita production of carbon dioxide, they could not do so without the co-enabling of co-conspirators in other countries. Downwind, droughts, and distant flooding from the carbon dioxide matrix have had their origins in the oil wells. From the past to the present, at new oil fields, the vast amounts of natural gas are uncommercial, so they are flared off. The long-term impact of global drying and global warming has been apparent in the last 70 years downwind from major oil fields as the massive plumes of carbon dioxide pour into the atmosphere from venting and flaring. Oil field venting and flaring create plumes of gases that travel like the plumes from volcanoes. The plumes travel great distances, waffling like an excited dog's tail, or an unattended vacuum hose. The carbon dioxide plumes are like atmospheric vacuums, sucking up moisture and desiccating the landscape until the soda bottle shake produces a carbon dioxide explosion of terrain. The relevance of volcanic plumes traveling thousands of miles, usually around the world, can be seen in similar space photos of oil wells burning. The best examples were the oil field fires in Kuwait during the 1991 Gulf War. This montage shows the Kuwaiti field fires flowing freely with the prevailing winds across the Arabian Peninsula onto the drought-stricken Horn of Africa. The world's prevailing wind patterns are important in downwind droughts and distant flooding. This crude graph shows the wind patterns averaged for seasonal variations. These winds are the immediate messengers of death to downwind areas from oil fields, local drying, and distant flooding that presage a dire, rapid global shift. Note the prevailing wind off of the Arabian Peninsula onto the Horn of Africa. This rough image from a February 1973 Popular Science article describes the mechanism of the CO2 matrix behind downwind droughts and distant flooding from oil fields. The article references research by American, British, French, and Russian governments to eliminate airport fogs by burning massive amounts of natural gas. The research was a success. Unfortunately, the cost was prohibitive. In pre-1973, cheap oil prices before the Arab oil embargo, it cost $1,500 to clear an oil field for 15 minutes. The important thing to remember as you read the list of oil fields and downwind droughts is how the fields daily burn billions of cubic feet of natural gas that has no commercial value. The ill-fated Columbia Space Shuttle, February 1st, 2003, had detailed how Amazon forest fires create holes in the clouds like the airfield fires, eliminating the fog, a cloud on. While the look of the oil fields has changed in the last 70 years, since the giant Texas field that ushered in the first Dust Bowl, the same atmospheric impact has been the same in the U.S. Midwest, East Africa, West Africa, Alaska, China, Korea, Western U.S. and Canada, the U.S. East Coast, Brazil, Central Asia, and Australia. The prevailing winds show the impact. Dust bowl conditions have visited the U.S. Midwest, 1930s and 1950s. In both cases, the droughts were precipitated by discovery of two major oil fields and ended by international events which sent Texas oil production down by 60 or 70%. The 1930s Dust Bowl began in the East Texas fields. This drought ended in 1939 with the end of exports to war-torn Europe. The 1950s Dust Bowl began in the West Texas fields. This drought ended in 1956 with the massive imports of cheap Arabian crude. George H.W. Bush was an oil man who made his bones in West Texas Permian Basin oil boom. Note that the prevailing wind pattern, Tornado Alley, corresponds to the Dust Bowl drought envelope. While the U.S. Northwest has the Alberta Clipboard to describe the consistent prevailing winds, the prevailing wind behind Tornado Alley is called the Texas Panhandler, for an area of Texas that also has some of the largest oil fields in oil. In 1967, East Africa began experiencing a drought that has ebbed and flowed, but increased nonetheless. This drought has created vast social, economic, and political upheaval. The upper left map shows the countries that were first affected. The upper right map shows the prevailing wind patterns off the Arabian Peninsula, which has the world's largest oil fields. The lower left map shows these fields along with a picture of the uncommercial natural gas being flared off, daily releasing 4 to 6 billion cubic feet of carbon dioxide. These recent photos show the drought belt that has expanded since 1967. Again, note the prevailing wind patterns off the Arabian Peninsula into the equatorial Africa. The lower left shot is a NASA shot of the fires in 2002. Africa is on fire. The East African drought has continued unabated since 1967, except for one period, 1973 to 1974. That was when America experienced gas lines due to the Arab OPEC embargo, when oil production dropped by 75% to 90%. Like the end of the first U.S. Dust Bowl drought, a drop in oil production ended the drought. Like the boom of West Texas oil, the Dust Bowl came back, as was the case in East Africa when Saudi Arabia resumed full production in 1974. Africa has been beset by two similar but distinct droughts for about 30 years below the Sahara Desert. The Horn of Africa drought is in the east, having its oil field source in the Saudi Arabian Peninsula countries. The drought in the west comes from two sources, the Libyan Algerian fields and the Nigerian Delta. The latter, operated primarily by shale oil, generates a quarter of the world's total of flared. Is it a mere coincidence that the largest oil field in North America came online 30 years ago, and in the last 30 years, Alaska has suffered the largest temperature rise in the world? No. Consider the following daily flaring of carbon dioxide from only one pool of oil in Part1 Bay, the Lisbon pool, 1 billion cubic feet. Figures cannot be found for the other fields. For comparison, Saudi Arabia reports releasing 4 to 6 billion cubic feet. At the height of the Dust Bowl of the 1930s, one historian estimated that in 1934 approximately 1 billion cubic feet of unassociated gas were stripped and released to flare daily in the Texas Panhandle alone. Ominously, the lower left photo shows where the Bush eaters want to increase America's dependence on oil, the Arctic National Wildlife Refuge next door to Part1 Bay. Don't cry for Argentina, cry for Alaska. The worst drought affecting humanity is the growing drought in China. It can only be lessened by the Chinese eliminating oil production in the newly developed western fields of the Tarim Basin, which is the same geological formation as the West Texas, New Mexico oil, Permian. Because China's oil production is primitive, the vast majority of the natural gas is flared or vented, creating vast plumes that blow from the western China across eastern China and Korean peninsula. The drought in Korea has led to the social, economic, and political chaos that has flared upon the world stage as a nuclear crisis in 2006. The two maps, one from Canada and one from the U.S., show that the drought does not stop at the border of the two nations. Canada's main petroleum fields are in the west, as indicated by the name of the professional hockey team in Edmonton, Alberta, namely the Oilers. Another piece of the puzzle is the name of the prevailing jet stream that comes over Canada and drops into the U.S., namely the Alberta Clipper. The image in the lower right is of the volcano plume of the 1980s Mount St. Helens eruption as it was bent by the Alberta Clipper. One of the weirdest experiences for this writer was encountering these two images of western Canada within a few days of each other. One shows the western Canadian oil fields, the other shows the fire potential. The overlap, given the summer wind patterns, is not a coincidence. The fires of 2003 out west are nothing compared to the future conflagrations. Why? The rising carbon dioxide level is becoming a self-sustaining tornado. As the biomass is stressed and dried out, it is less of a carbon dioxide sink and more. In 1999, a third dust bowl began to make its appearance in the Midwest. The origin of this carbon dioxide matrix, for it had massive flooding, was the development of electricity generation plants atop natural gas pools for exporting to other states. The wildfires in Arizona and New Mexico, 2002 and future, can thank the border-straddling power stations which sprout carbon dioxide that knows no nationality. Beginning in 1998, the southeastern United States began suffering a drought that expanded up the whole eastern coast. The culprits are the rapidly increasing number of deep-water oil wells in the Gulf of Mexico. These wells have had a rapid increase in production in only a few years, producing almost a quarter of the U.S. domestic consumption. Primary wind patterns are the westerly trade winds. The easterly trade winds come off the equator. The winds shift in the Gulf is why hurricanes come from the coast of Africa and eventually reverse course, double back to the east once they enter the latitude of the westerlies. While relative few in number, the Gulf of Mexico deep water wells, about 50, are monsters in contrast to their onshore counterparts. These monsters flow at 30,000 barrels of oil a day, 100 times greater than the average onshore wells. The amount of gas that is vented or flared is not really known. For reasons only known to the Department of Interior and its Mineral Management Service, rig operators are no longer required to keep accurate records. For reasons only known to the Mineral Management Service, previously available documents on flaring have disappeared from the Internet. As Brazil developed high-volume deep-water wells off the booty of South America, a drought developed in size that reflected the increased oil production. Until it mysteriously sank, Brazil had the largest deep-water oil rig. Because the natural gas could not be used, it is flared off. The clip of the global wind pattern shows the green line of the equator where the winds go the opposite direction of the Earth's rotation, that is, west across Brazil from the Atlantic Ocean, where the drought developed. Since the 1930s U.S. Dust Bowl, that was downwind from the world's first massive oil fields, discovery development of each explosive exploration has caused downwind droughts with economic, social, and political chaos. The latest and greatest is world terrorism. Central Asia is seasonally buffeted from oil drought winds from two sources, China's Permian Basin and the Caspian Sea. As the lower graphs show, rising petrol production produces droughts. The Taliban in Afghanistan could not have misused the Quran without the economic and social chaos wrought by the droughts from upwind oil fields.
End of Oil Drought Part A. Please view Part B.